So I'd like some more feedback about the connection, and then I'll maybe start and introduce the topic of the webinar and myself. I see only one answer. Maybe the people are not able to write in the chat. Please, Sergey, can you check that? But we got one answer. So I'm going to welcome you on this webinar today about refrigeration industry innovations. My name is Vanessa Heathcock. I'm the event manager of the online catalog Refrigeration Industry. I'm very happy to greet you here. Thank you very much for coming. So we're going to talk about the latest refrigeration innovations, the latest technologies. You will learn about new solutions for commercial refrigeration at EuroShop 2023. And you will have a chance to ask some questions directly to the manufacturers of refrigeration technology. And before I introduce the speakers, I hope you can write in the chat now. I'd like to know where you're from. Please write in the chat where are you watching us from, maybe the city, the country. Oh, we've got the first answers. So Denmark, Germany, great, Poland. That's great, thanks. What other countries have we got here? Germany. Okay. Wales, UK. That's a hard name to pronounce. Thanks. Italy. Great, that sounds nice. And I have another question for you. Is anyone who is watching us planning to visit the exhibition EuroShop 2023? Are you going to be able to visit it? Please tell us who's coming. Okay, somebody's coming, great. Someone says no. So this webinar is a good chance to see what the innovations are and what you're going to see on the stands. Okay, yes, for sure, maybe, yes, great. So this webinar will be useful as for people who are visiting, because you'll be able to see what will be waiting for you there. And if you're not coming, you'll be able to ask your questions maybe now on this webinar. So I want you to be very active on this webinar. You can ask any questions you like. So we will try to answer as many questions as we can. And I think I'm going to introduce our dear speakers. So the first speaker will be Jörg Wittmann, Manager Key Accounts and Market Sector Supermarket BITZER. Please tell us what the topic is today. What's your topic?
Good. Thank you very much, Vanessa, for the introduction. Our topic today is, let's say, I'm talking about mastering the challenges of part load operation in CO2 systems. Because there we see really challenges in the market, and I'd like to work this out and, yeah, offering some solutions.
Great, thank you very much. So moving on to the second speaker, it's Kaven Nourrice, Application Engineer of Frascold. What are you going to talk about?
Hello, everybody. Hello, Vanessa. Our topic today will be take an outlook of the Frascold solution for commercial and light industrial refrigeration with natural refrigerant. So with the difference between natural refrigerant to find out which is the best solution for different application.
Great, thank you very much.
You're welcome.
And I'm presenting the third speaker. There are actually two people here. It's Isabelle BERNHEIM, International Marketing Manager, Saint-Gobain Glass, and Hadrien HEUCLIN, Research and Development Portfolio and Program Responsible, Saint-Gobain Glass. What are you going to be talking about?
Yeah, hello, good morning, everyone. So Isabelle and I will be discussing the role of glass in the energy performance of the cold cabinets.
That's very interesting. Okay, so thank you very much. You've met the speakers a little bit, and I think we can move on and start. Please be active during the webinar and ask your questions. We'll try to cover all of them. So, Jörg, your word.
Good. Thanks, Vanessa. Then I will directly share my screen and start right away. Yeah, thanks for the introduction. Yeah, my name is Jörg Wittmann. I'm working now for already 10 years at BITZER. And let's say my daily business is the coordination of key account management related activities in the BITZER organization. And I'm also following the market sector food retail. So this is why EuroShop to a certain extent is my baby. Good. The topic today, mastering the challenging part load conditions. And this will be now also the first slide. Let's work out which challenging conditions we see. Let's say the new systems which are installed very often are installed in an integrated way. So the CO2 systems now are not only designed anymore for LT or MT application, but they also work as for air conditioning and in many cases also for heating. How do we heat? We have to integrate a heat recovery system. And in many cases, these are even multi-stage heat recovery systems. And very challenging for the CO2 installation, heat recovery installations without water-side buffer tanks. As soon as the buffer tank is left aside, then the heat recovery is quite frequently switching on, switching off, purely based on the demand on the store. And this creates a certain challenge on the regulation of the CO2 reg. Of course, this was the target of the industry to provide installations or provide technology that we could do installations also in high ambient temperature regions. So this is done now with success. Therefore, very often ejectors are used. So also these ejectors need to be integrated into the control, and let's say ejector operation needs to be balanced in the control. Aside of these, we also see increasingly the demand for low space requirement. And of course, we always have this pressure, reduce investment cost. These two factors very often lead to the situation that our customers try to reduce the number of compressors on a rack. But of course, the less compressors I have, the less possibilities I have to make smooth capacity control. So we will see this in the slides following then this slide. On the other side, of course, environmental issues, power saving always is an issue. So we want to increase the efficiency in peak load, but especially also in part load. We want to reduce the operation expenditure and, of course, the CO2 footprint. This is the drive for more energy efficiency in a green way. And very much an everyday issue. We still see a lot of shops where glass doors are retrofitted. And this also creates a big challenge for the control of CO2 reg, because then the minimum capacity requirement is dropping. And in case the system is not adapted to this reduced capacity, then of course the compressors, the lead compressor will start with on-off cycling. And of course, a very frequent on-off cycling of the compressor is not ideal and might reduce the lifetime of the compressor. So all in all, out of this analysis, we come to some clear goals for an ideal rack design. We should target to reduce the minimum capacity on the rack to fit to the lowest minimum load in the system, in the supermarket. So create this minimum load, this minimum capacity without on-off cycling of the lead compressor. This is a clear goal. Then, of course, we want to have a smooth ramp up of capacity from the smallest capacity requirement up to the peak load without any jumps. Yeah? We will go into detail in the next slides. And of course, we always have to cover the peak load. And in ideal case, we create best efficiency in all operation conditions. So this brings us now to the slide. What can BITZER do with what can we do with our product portfolio to help you, to help our customers? So for the efficiency requirement, we have introduced already 5 years ago the EcoLine Plus compressors. So compressors with a line start permanent magnet motor. And these kind of motors are highly efficient, as more efficient than asynchronous motors. And the very nice part of it, the integration is absolutely identical compared to an asynchronous motor. So there is no additional complexity. It's just using an EcoLine Plus compressor or retrofitting an EcoLine Plus compressor. The other possibilities we have when we talk mainly about part load efficiency, then of course we have a large series of Varipack frequency inverters available. Then the innovative Vari-step system for CO2 from 10 to 100%, where we can increase and decrease capacity in a very wide range. And this is so a mechanical capacity control on the cylinder heads. But in reality, on a rack, you can say it's quasi stepless, so it's very close to stepless operation. And then last but not least, we also will see the application in the next slide. We have CR 50%, 100%. So this is the classical unloading of a cylinder bench at a 4-cylinder compressor. So there we can do 50% or 100%. Of course, when we go to a 6-cylinder, then we have one additional cylinder bench to switch off. Then we could do 33, 66, and 100%. Good. So how can we use that? How can we evaluate whether a certain rack design is good in, let's say, in the quality of regulation? Which one is less good? We have here a guideline where we can refer to, and this is the ASACOM guideline for design of multiple compressor racks, using frequency inverters. And here is, let's say, the key sentence. What is this so-called control factor, CF control factor? What is it about? It talks about, or it equals the difference between the capacity of the lead compressor at maximum and minimum frequency. And this divided by the capacity of the following fixed speed compressor. So this means if I can cover a certain capacity range at the lead compressor between minimum frequency and maximum frequency, let's say this is 10 kilowatts, and the second compressor, the following fixed speed compressor, also is 10 kilowatts, then the calculation will give 10 divided by 10 is 100%. So this would be ideal. You also can get configurations with control factors of 130, 150. We will see this later on. But this means, in another way, when I'm below 100%, then I will receive already first fluctuations. Of course, a system can tolerate a certain fluctuation of suction pressure. So ASACOM defines that if we are somewhere around 80%, then we still can consider the control factor as good. If the control factor drops below, then it's getting more and more critical. So please let's have a look here on these diagrams, because these kind of diagrams are used then during or with the next slides as well. Here on the left side, you see the VSC, the variable speed compressor. On the right side, you see with increasing capacity demand that the base load is covered here from the fixed speed compressor, and the variable speed compressor is working, you can say, on top, and is creating the possibility to regulate. And we can see here that when the capacity is increasing from minimum capacity with the variable speed compressor, slowly, and then we come into an area where the controller can still work with the variable speed compressor alone, or the controller can move to the setting fixed speed compressor plus variable speed compressor. Yeah. So we have here an area where the controller can choose both, but there is the possibility to smoothly increase the capacity. Here is an example with a factor of 80%, which still is good, but it will not guarantee a smooth ramp up, because here I can see the capacity is increasing up to the maximum of the variable speed compressor. And when I now switch on the fixed speed compressor and I reduce down to 25 Hertz the variable speed compressor, then I have a higher capacity. And this jump I get each time when I add an additional fixed speed compressor. So in this configuration, always when my load from the system is here in this zone, so on this level, then the system controller has to change, or has to switching off the fixed speed compressor. Then we are here and going to 100% at the variable speed compressor, or switching on the fixed speed compressor and reducing the frequency of the variable speed compressor. So here we get into a slight instability. So let's have a look on a typical supermarket installation. So minimum capacity in winter time typically is 15 kilowatts in the specs. But we see very often that systems are seriously oversized, and we see also very often that at a later stage, glass doors are retrofitted, or sometimes, especially when we talk about a booster system, that the situation of purely covering the low temp load, so with the empty compressors, from the booster compressor, that this is not really considered, and the low temp load very often is somewhere around 5-6 kilowatts, So this is why I have added here this line. In the future, in a future installation where I consider the minimum capacity, I will be very often at 10 kilowatts and even lower. In our example here, the maximum capacity for summer shall be 100 kilowatts. The selection is a typical selection, -8 empty. So here in our, for simplicity reasons, we are having not considered a low temp stage. It's a pure empty installation. Now let's go through. Let's take a typical rack design. So typical rack designs we have had and we still have would be 100 kilowatt. I take a 4 JTE with a frequency inverter, 25 to 70 Hertz. Then a 4 FTE fixed speed and a 4 DTE fixed speed. In the first view, I would say, okay, minimum capacity 15 kilowatts is covered, 100 kilowatts is covered. Okay, great design. But in fact, when we go in detail, and this is quite visible here on the diagram, the winter line, the subcritical line on the top, the summer line, transcritical on the bottom. Always when we come in these areas here, whether it's subcritical or transcritical, then we get into a jump situation. So quite visible here, in case the subcritical winter demand is 130 kilowatts, the system cannot cover these 130 kilowatts. So it will switch off the third compressor and work with 113 kilowatts. The suction pressure will increase, and then the controller will decide to switch on the third compressor. And then the system will have 160 kilowatts, the suction pressure will go down, and then we get this switching situation, which is not good, it's quite unstable, and it's reducing the efficiency. So we can conclude CF factor is quite low. It's a bad solution for capacity control. So what could we do? the standard answer is, okay, we have to find a smooth ramp up. Then let's use 4 times the same compressor. Yeah. Then I get a very smooth ramp up because the next compressor exactly fits to the bandwidth of control of the frequency inverter. Yeah, I have a good CF factors around 100%, ideal. But when I go to the minimum capacity, I still am far above the 15 kilowatts and far above the 10 kilowatts. Yeah. So this will be a good system in summertime, but in wintertime, efficiency will be not very good. And I get a lot of cycling. So the next possibility I have, I could use on the second compressor capacity regulation 50, 100%. So unloading the cylinder benches. Here I can create a very good CF factor, and I can go down with the minimum capacity down to 15 kilowatts. However, we also have to say here there is a certain challenge, because then the controller needs to work with 6 stages. Yeah. And also there we have different, even if you have a if they have the possibility in your controller, we need to have for such kind of a design a controller using kind of a best fit setting possibility that you can really program the right way of switching on cylinder benches and then complete compressors and switching back. So this logic behind is not always possible to set it in the controller. In case there is the possibility, then this is a good solution. Which other solutions do we have? Now we use our Vari-step technology, so this innovative capacity control on the cylinder heads. Here we can work now with 3 compressors again. Could be more cost effective than the solution before. Yeah, we see it very quickly. Control factor is excellent. Minimum capacity is even at 8 kilowatts, so really good compared to previous solutions. And all in all, we can create this way, yeah, an easy and cost-effective system. So an ideal setup for future challenges. And now comes the nice point. The system here looks, thanks to Vari-step and the IQ module on the compressor, looks very nice and tidy, compact. In case you don't have access to this technology, then you have to work with frequency inverters. And this brings us to the next slide. Then the solution would look like this one. Yeah, then you would, with a frequency inverter, with a classical setup, you would need in total 8 compressors to cover the same range. Good. I'm seeing that the time is running a bit out. I'll quickly want to show in a very quick way the potential of this Vari-step technology. Yeah. So the target always is to come as low as possible in wintertime with part load. And here is a first step. So when you compare the Vari-step technology and the 50%, 100% capacity regulation on the second compressor, then you can go even lower. We arrive somewhere at 6.9 kilowatts. Yeah. And on the final slide, we will see the full potential. So this would be the best possible setup with the widest range of capacity regulation. You can see in winter time you could go down to 4.3 kilowatts. In summertime, yeah, nearly the 100 kilowatts. Great CF factor. And let's say thanks to the IQ module on the lead compressor, you even get an additional protection. You get data log, which helps you to improve let's say the setting of the controller. Yeah, so it's a nice solution. And especially, I want to underline that when we have a booster configuration with an LT compressor or an LT load, which is very low, then this is more or less the best possible setup where you can, in a stable operation, create the minimum capacity. Good. So thanks to the vari-step system, we can work with a lower number of compressors. We can guarantee very accurate suction pressure, less starts and stops, so higher reliability and lifetime. All the challenges we have had in the first analysis, heat recovery and so on, ejectors easily can be controlled and regulated. So in the end, let's boil it down, less trouble and highly efficient systems. Good. In case we cannot solve your questions today in the webinar, everyone is highly welcome to visit us on our booth. We are at Hall 17, booth D59, and especially these capacity regulation topics, but also some other ammonia screws or gas coolers, whatever. We have the complete interesting, innovative portfolio on our booth. You are highly welcome. Thank you for your attention.
Great, thank you very much for your presentation. We have a couple of questions. Shall I help you to read them, or can you see them?
Okay, I read the first question from Hadrien. Thank you very much for this question. So I read it out loud for everyone. When BITZER will launch condensing units with CO2? This is a question which we are asked quite frequently. And yeah, I have to admit, I can't tell you because let's say so far our decision is we cooperate with our customers, and we see some great BITZER equipped CO2 gas cooler units on the market, and we currently see also on the market that with our Ecolite and EcoStar A2L, so especially Ecolite A2L ready condensing units, that we are fulfilling, let's say, the market demand, and the condensing unit on CO2 is missing, and there is no product launch planned. Good. Then Lawrence is writing, so when you most need heat recovery, the load is very low. Yeah, okay, Lawrence, this is absolutely clear. Let's say a typical supermarket installation is highly challenged in summertime, yeah, because then transcritical capacity is lower than the subcritical capacity of the compressors. During winter time, in case you don't have a heat recovery connected, then you will reduce the condensing pressure as far as you can, and you will work very efficiently. However, in the end, it's a pure comparison. When you connect a heat recovery into your booster system or into your empty system, it might be, or it still is, more interesting to slightly rise the condensing pressure, because you still get, let's say, 70–80% of your heating, you get it free of charge because the cooling has to work anyhow. Yeah. So this is then the challenge or the interesting part of installation design, to work out up to which heating capacity heat recovery makes sense, also from the investment point of view, and where do I use maybe a gas burner as a backup. Yeah, this depends on the installation design and on the efficiency in the end. Yeah.
Okay, great. Thank you very much, Jörg, for your precious information and for your presentation.
You're highly welcome.
Okay, so we can move on to our second speaker. Please, Kaven, Nourrice, I give the word to you.
Okay, let me share my screen and presentation. So good morning to everybody. I just represent myself for the people that come later. I'm Kaven Nourrice, application engineer at Frascold. Today we will take an outlook of the Frascold solution for commercial and light industrial refrigeration, considering the upcoming EuroShop. More and more, just an introduction about the policy framework. More and more, the carbon footprint, it is something that it is necessary to take in account. In the total balance, it is necessary to evaluate the direct emission that are direct related to refrigerant losses and GWP, and indirect emission related to the energy consumption and then to efficiency. EU put in charge different acts in these years to push the industry to reduce the total greenhouse gases emission, like, for instance, F-gas and all the related with eco-design and eco-labeling. At the moment is under discussion the revision of F-gas. I think everybody know it. The proposal will be discussed within this year, but it seems that the general idea, the general inclination is to tighten the quota system for the next year and extend it after the 2030 with the progressive reductions. The target is to reach minus 98% of HFC's quota put in the market in 2050 compared to the 2015 level. Referring to commercial refrigeration, review of F-gas seems will not change a lot the scenario of the original F-gas of 2014, put as a target of 150 as maximum GWP value for most application. Low GWP refrigerant and especially natural refrigerant are now completely available for all commercial and commercial application. The question for the audience and for me, I try to answer during this webinar is refrigerant of the future. Which ones to choose? The focus is on natural refrigerant, of course, CO2, propane, ammonia. Also because the request of 5 European countries to put in the reach all the substances that contains FAS molecules, put in a tight corner HFO. So natural refrigerant seems the solution, at least for commercial refrigeration, the real long-term solution. Just to take a closer look to CO2. I summing up the advantages and the challenges of CO2, and then we will do the same for propane and ammonia. For CO2, of course, the high market availability, the good performance in integrated system, like my colleague said before. Low GWP, it's of course a long-term refrigerant, a cheap refrigerant, and CO2 has a very good thermodynamic properties in terms of heat transfer, viscosity, density, very high volumetric refrigerant capacity. But we need to face some challenges like the high operating and sensitive pressure of the system, complex cycle for gain high efficiency and to perform integrated system, and the necessity to have more qualified technicians that are able to operate in a CO2 system. And of course, the necessity to have dedicated components. CO2 needs, for the reason that I explained before, need a specific and dedicated design with some design feature that can be derived by automotive sector. Some of the features applied for CO2 subcritical compressor are, for instance, anodized surface of the pistons, the shaped top surface, and the 2 piston rings for very low oil carryover. At EuroShop, you will see the extension of the range with SSK-free up to 48 cubic meter per hour and 30 horsepower. This to meet the request from the market to have bigger compressors even for low temperature application, like cold room and cold storage, or paired in a booster system for bigger supermarket. The specific design, it is even more necessary when it comes to transcritical application, in which pressures and temperatures are higher. This is why, in addition to anodized surface to the piston have also anti-friction skirt, and the bushing are designed for high pressure, high mechanical resistance. To allow very low oil carryover, guarantee the sealing, considering the higher delta P from low side and high side, but having low power consumption and long-term reliability, 3 piston rings are in place with special anti-friction coating. Transcritical range, Frascold transcritical range covers from 2 to 38 cubic meter per hour with the new 6 cylinders ZTK up to 50 horsepower. The extension of the range, both in subcritical and transcritical application, allow the design or bigger integrated system that are commonly used in commercial refrigeration and in some industrial application. CO2, it is very present in all the cold chain. This is an example of a real installation. It is an integrated system with walk-in freezer at -20 Celsius, cold rooms at medium temperature level up to 4 Celsius, and a processing room at 12 Celsius. With the same, all these loads are performed with the same rack. Are in place 10 compressor divided by 4 level, because we have also the parallel compression level with 3 level of evaporating temperature. The overview of CO2 is what we want to show you. And now let's start with the hydrocarbons, and special the propane. The advantages of propane are, of course, the high market availability, the possibility to perform a simple thermodynamic cycle with very good performance. The pressure are more or less the same of an HFC system, so a traditional system. Low GWP, of course, because it's natural refrigerant, and it is a cheap refrigerant. The major challenge of the hydrocarbons in general and propane are the flammability, because all the hydrocarbons are classified A3, so high flammability. Frascold offers the wider range of ATEX Zone 2 certified compressor in the market, starting from the reciprocating compressor from 2 to 8 cylinders, and passing through the compact screw compressor, CX H and W series, and semi-hermetic screw compressors with external oil separator, all ATEX Zone 2 certified. Having this wide range, it is possible to offer solution in any application. The core of the development of ATEX series, of course, is the ATEX Zone 2 certification that take in account the risk related to compressor, electrical box, and accessories together, making easier the customer's risk assessment, because all the parts related to the compressor, electrical box, and accessories are already taken account by our certification. The other pillar of this series is the dedicated lubrication and oil management. This is a real example of a screw compressor system with propane in, let's say, food processing industry. In this case, it is a chiller for wine sector. This chiller is equipped with 2 compact screw compressor with full inverter. With microchannel condenser, it was possible to reduce at minimum the charge. The criterion to design the system with the minimum charge for hydrocarbons, clearly it's very important, because the aim is to limit as much as possible the charge, usually with screw compressors to stay below 20 kilo for circuit. Last but not least, we consider ammonia as natural refrigerant for commercial refrigeration and light industry, like cold storage or something like that, for this industry. And we can summing up the advantages of ammonia. Also in this case, the high market availability, the very good performances, null GWP and ODP. Long-term refrigerant, it's well known in industrial application, and outstanding thermodynamic properties like heat exchange and volumetric refrigeration capacity. In this case, we have some challenges like the toxicity and light flammability, because ammonia is a beach well refrigerant with also pungent odor. Design feature to minimize the risk of leakage for the toxicity, dedicated components for ammonia application, and also in this case, the necessity to have more qualified technician. In the cold chain, ammonia has a place since ever, basically. In some application, like, I don't know, poultry transformation is still the most used refrigerant. And usually when the sites start to increase in terms of capacity, ammonia is the best choice. In Frascold portfolio, there are the well-known open type compressor up to 360 cubic meter per hour, and the new semi-hermetic screw compressor with aluminum motor windings. They use an introduction of a semi-hermetic compressor. It's a very new idea, and allow to remove the major possibility of leakage, the seal, and making simpler and more compact the design of a classical ammonia application. Try to realize a ammonia chiller in an easier way. Here an application with very low charge ammonia system. The challenges are to keep the refrigerant charge as small as possible and to have the maximum efficiency. With fluid evaporators for high efficiency and the introduction of a cooling tower to reduce the condensing temperature, allowing to have excellent COP and deliver more than a megawatt in cooling capacity with only 74 kilos of ammonia. I go to the conclusion because I think the time is quite over. We think that to overcome the future challenges in terms of choice of the right refrigerant, it is necessary to pair the right refrigerant to the application in which the characteristic of the application best fit the characteristic of the refrigerant, and we think that Frascold can be the right partner to find the best solution. Thank you. And
thank you so much.
If you want, if you come to EuroShop, you will find us in Hall 15, booth A39.
Thank you so much, Kaven. We have one question. Shall I read it for you?
Okay. No, I can read it.
Okay.
The question from Jan. I read for everybody. It is a well need to claim the compressor for ATEX Zone 2 while using propane. Thank you, Jan, for the question. I think it's the point. Basically, it is not mandatory to use an ATEX Zone 2 certified compressor when it comes to use of propane or another flammable refrigerant, but it is a safety matter. If you use components ATEX certified, the risk assessment is easier, and you are able to manage the flammability in an easier way. There are different approaches. We saw different approaches by different chiller or heat pump or refrigeration rack producer, because basically it's up on the risk assessment. Clearly, more the components are safe or are certified ATEX Zone 2, easier it is managed the risk.
Okay, great.
Hope to answer to the question. You're welcome.
Yes, I think the person said thanks.
I saw it.
Thank you so much for your presentation. And we're moving on to the third participant, and there will be two people here. So Isabelle BERNHEIM and Hadrien HEUCLIN. Your word.
Hello, thank you, Vanessa. Thank you for the introduction. So we are very happy to be there today to show you to show you who we are and what we will propose on our stand in EuroShop. So I'm here with Hadrien HEUCLIN, who is managing the R&D for cold refrigeration, and myself, I am managing marketing for that field. As you can, just a very brief reminder, who is Saint-Gobain? Saint-Gobain is a worldwide leader of material mainly for construction, but we also have the activities in mobility and in industry, and typically, so we are extremely active in cold refrigeration with, we believe, some interesting propositions. Saint-Gobain Glass, as you can imagine, we have some glass expertise and we work really with all the know-how we have to propose some performance glasses for glazed cabinets. So we design the glass, we manufacture it, we distribute it, and hopefully more and more we recycle it. So what will you see on our stand? You will mainly see glass. Obviously, you will see, so this is our stand. So we show many type of glasses, either for positive cold refrigeration cabinet, semi-vertical cabinet, wine cell, vending machine, freezer islands. So many type of application where we develop specific glasses. And to make it short, on what do we work in Saint-Gobain Glass? We work to offer the best energy efficient glass and best transparent efficient glass, so that our client can have cold cabinets which are very efficient in terms of energy. It can decrease their energy consumption, And at the same time, we offer the maximum transparency to the client. So maybe, Hadrien, to start, you will show us that all the glass are not equal.
Exactly, all the glass are not equal. So it's a short slide on the thermics of glass, and the aim is not to give you a lecture on everything that happens. But basically, when we talk about thermal insulation of a cold cabinet, there are three main, let's say, physics law behind that. The first one is the radiation, which is the main phenomenon for heat transfer. So in the case of, let's say, a window, it's usually the heat coming from the sun. In the case of a cold cabinet, it will be more the reflection of the heat from the glass that is hotter on the outside than on the inside. Then you have some phenomena of thermal conduction that is reduced by the presence of a cavity between the two glasses. Maybe to explain here, what you see on the left is the typical structure of what we call an insulating glazing unit, meaning you have two parallel panes of glass that form a cavity that is usually filled with an insulating gas like argon, which is the most commonly used in the market. It can also simply be filled with air. And those two glasses are separated, what you can see at the bottom, with a spacer and a desiccant to prevent the apparition of humidity inside the cavity. And so this construction allows to limit, let's say, the thermal transfer between the hot environment of the store and the cold environment of the cabinet. We measure the energy efficiency, let's say, of a glazing by a unit that we call UG. And to make it simple, the lower the UG of a glazing configuration, the better the insulation properties. And our specialty at Saint-Gobain is, as Isabelle mentioned, is to manufacture the glass. But we also have the possibility to use what we call low emissivity coatings on the glass. What we call a coating is a deposition of several nanometer thick metal layers on the glass. And this, let's say, the know-how that we have developed at Saint-Gobain on the manufacture of such coatings allow us to have a strong impact on the energy efficiency of the glazing, while at the same time trying to maximize the amount of light that will go to the glazing, so to keep a maximum transparency, as Isabelle already mentioned to you. So now if we go to on numbers, what that means, it means, as Isabelle said, that there's no one glass configuration that fits all, and depending on the choice of glazing, you will have very different performances. So if we look at this graph, it's on purpose very simplified. You can basically go from the simple monolithic glass, 4 millimeter glass, which is, let's say, the standard in a lot of glazing application, and you have here a UG value of 5.8, which is pretty huge. If you now go to, as I mentioned, the insulating glazing unit, so in this case, you have two glasses plus a cavity plus a spacer, etc. If you add two glass, you divide basically by 2, let's say, the UG of the glass. If you go to a triple glazing, again, you maximize the efficiency of the cabinet. And in the end, when you add low-E coatings, it's, let's say, the last step of the rocket. Now you reach UG values that are extremely low. And again, as a reminder, the lower the UG, the better the thermal insulation of the glazing. And all our work at Saint-Gobain, as we said, is to balance the energy efficiency with aesthetics and transparency of the glass. And if I go through some examples, I guess it's better to show real-life examples than just numbers on a slide. At EuroShop, what you will see in our booth, the first product that we are presenting is a product that we call EcoPro, which has been specifically designed for horizontal freezers. It's, as I mentioned, a low emissivity glass, which has very high energetic performance, is neutral in color, has high durability, and also allows to limit the condensation effect of the glass. We did some measurements with an external lab to, let's say, validate the energetic performance of our glass. So what you can see on the left of the chart is when you have what we call a standard solution for this type of application, which is a glass with what we call the pyrolytic coating. I won't go into details of what is a pyrolytic coating, but anyway, it's what exists as a standard solution for this market. You have a consumption on this specific cabinet that you can see here of about 2,500 kilowatt per year of electrical consumption. And by switching only the glass from this standard solution to our EcoPro glazing, in the end, you have, and they have measured, a 20% reduction of the energy consumption of this cabinet. So that highlights the significant importance of the glass on a cabinet. So it's not simply the losses to the walls. The losses to the glass are significant, and we have solutions that help improve this specific part. Another product that we will highlight is what we call the Eco Diamant, which is mainly for vertical refrigerated display. In that case, it's also a low emissivity coating. This time it's deposited on extra clear glass. So extra clear glass, to make it short, has a higher transparency and a better aesthetic than standard what we would call our Planiclear glass, which is our standard glass. It has very high thermal insulation, and again, so very high transparency. And again, compared to standard solution, it's also the numbers that you can see on the right. This time, it's not the electrical consumption of the cabinet, it's more the evaluation of the heat loss through the glass. And in that case, if you switch from again, a standard product that is commonly used in this application with our Eco Diamant, we have simulated and calculated a 25% reduction of the heat loss to the glazing. So again, this highlights the interest of moving from standard glass to very high performing glass in those specific applications. And finally, because we have only 5 minutes left, I will let Isabelle continue on the last one.
So yes, very briefly. So thank you, Hadrien. As you can understand, Saint-Gobain is producing innovative glasses, but not only, and we innovate also in glass door themselves, especially in our premises in Romania, named Pieta Glassworking. And here you can see one of the products that we will show in EuroShop, which is Eco Crystal T. As you can see, this is a fully transparent glass door that is frameless with a specific transparent intercalaire. The energy saving of the door can be extremely high in the level that Hadrien showed us with up to an UG of 1.1. And also this type of door, Eco Crystal T, can be also made of low anti-reflective glass, what we call vision light, that will allow to have a perfect vision through the glass. The advantage of these glass doors is also their long lifespan, a lot of customization to the customer needs can be made, and it's an easy to install glazed doors. I think we have finished for now. We wanted to talk to you about a lot more innovation, so all around energy efficiency, integral transparency, but also on sustainability, where our group is progressing and having new info to share with you, as well as new glazed doors. So we warmly invite you to come and visit us in EuroShop. We are in the hall 17 on the booth D70, and you will be welcome all the 5 days. And don't hesitate to contact us at euroshop.saintgobain.com to ask for any question you would have, for an entrance ticket for the fair, for any other topic you would like to share with us. We'll be very happy, Hadrien and myself, to get in touch with you. Thank you very much, Vanessa.
Thank you so much, Isabelle and Hadrien. That was great. Thank you so much. We have a question for you. Shall I read it for you?
Yes, maybe it's for Hadrien.
Yeah, it's for Hadrien.
The question is, UG value is thermal conductivity. Well, in the first approximation, we can estimate indeed that the UG value is equivalent to the thermal conductivity of the glazing. So the lower the UG value, the lower thermal conductivity of the whole assembly. So in an approximation, yes, we can approximate it this way.
Okay, great. Thank you so much. So I can't see any other questions in the chat. Maybe if somebody has a question, they can ask, but I think we're going to we're going to finish our webinar. Thanks a lot to our wonderful speakers. Thank you so much for finding your time. We appreciate your time and your cooperation. And of course, thanks a lot for everyone who was here with us. So I think there are no questions in the chat. So I invite you to register and subscribe to the newsletter of our company, Refrigeration Industry. You will find fresh news about the refrigeration industry there. Thank you very much for everyone who has been with us today, and have a great ending of the day.
Thank you. Thank you very much, Vanessa, for organizing.
Thanks a lot.
Thank you.
Bye-bye.
Nice
Yeah,
seeing
thank you
you.
very much.
See you
Bye.
soon on EuroShop. Bye.
Bye.